Well, welcome everyone. It's great to see all of you here for our TCIPG webinar series on resilient power grids. Today really is a very special day. We have Dr. Himanshu Khurana, in fact, one of the founders of this series many years ago, coming back to make a presentation. Himanshu received his PhD. After that time, he was at the National Center for Supercomputing Applications, the room we're in now for a while, and I think it was very fortunate for then TCIP that we were able to convince him to come over and begin working full-time on the TCIP project, and that was quite a few years ago. A few years ago, he was recruited away to Honeywell, in fact, during one of our industry workshops, so I guess things go both ways in those industry workshops. But we view this as a major success that he went to Honeywell, and he's really changed the landscape of Honeywell, so he went there. He now is the Director of Engineering for Honeywell Building Solutions. He'll tell you more about what that means and what he does there, but it's a very large role in which he directs really all the research and the development work that's going on regarding the interface between the buildings and the grid. He's also a very strong believer in research that has an impact, and he was the co-founder of something called the Cybersecurity Research Alliance. And this is a group of several companies, I think between 5 and 10 companies now, that have committed to work together to fund and promote research that will have an impact in the cybersecurity area. He has a long history of accomplishments, and I don't want to take up all his time telling about them, but I just want to say very personally, it's fantastic to have Himanshu back. It's fantastic to have him talk about what he and others have done at Honeywell and really give a vision, I think, for the future of securing control systems such as those that are used in the grid. So thank you very much, Himanshu. You see we're getting the big crowd of reading group students come in. You know about the reading group as well, but we're really glad to have you here.
Thanks, Bill. It's great to be back. Thank you for inviting me. I've kept in touch with Illinois ever since leaving and had some idea of all the great work all of you have been doing as an opportunity for me to share a little bit. So I've been coming back at industry events and other workshops to learn more about what research happens here. So I think Bill sort of wanted his turn that, share a little bit about what we've been doing and how we've been approaching control system cybersecurity. So as Bill mentioned, my recent role is focusing on building management systems, where we look at how to improve the energy efficiency, comfort, security, safety of buildings and what the vision there. And I'll give a little bit of hint on that, but you'll see through the talk a little bit of the history of the kind of things I have been involved in over time, where we've played with different types of control systems and trying to provide additional trust to them and do it in a practical way to build solutions. So here's a brief overview, right? I'll just do a context setting. Many of you probably know what cyber physical systems are, but put the context from where I'm coming from and the system we play with. And think about how to position R&D challenges from the industry perspective. We talk about CSRA some more here. I'll give you 2 examples of how Honeywell has been taking a systems approach to developing practical solutions for security, which is always hard to do. And then the model that we have in place for thinking about tech transfer in general. Even from the industry research labs, tech transfer is not guaranteed. As many of you know from your contact with the industry, having eventual commercial impact is always a big challenge no matter where you are. We'll switch gears a little bit and talk about what Internet of Things might be, right? And what it is today, what it might be someday, and then what kind of challenges are there. Is it an interesting space? I have no conclusions here to offer today, but just some questions that we can all discuss on what the future might be and why or if this vision is interesting. Very briefly, Honeywell focuses on several key big domains. Just a little background on where I'm coming from. There's the aerospace domain. We're looking at engines, navigation systems, flight management systems. The automation control solution part is where my home is, looking at that, and that group looks at home comfort, building management, and operations. Performance materials and technologies focuses on process control, focuses on biofuels, focuses on specialty chemicals of all kinds, including the stuff that goes into medical packaging. And then transportation systems looked at turbochargers and other vehicle management systems. So it's an industrial conglomerate that looks at things broadly. And these are the types of cyber physical systems we get to play with, right? And get to understand what their behavior is, what the expectations are. So in homes and buildings, you have your HVAC and comfort systems. Smart appliances are coming into play there. Physical security for the home intrusion, energy and comfort in general. In industrial systems, similar things happen, but with the different priorities. There's process control, there's refinery management, SCADA systems, DCS systems. These tend to get broadly used when you look at our larger civil infrastructure around electric, oil and gas, and energy delivery. Safety systems, fire safety, fire protection. And if you go to places like airports and think about how safety and mustering works there, it's a non-trivial system setup, right? A lot of real-time issues that people don't often realize. Productivity, this is looking at the worker and what tools do people need. If you think about what a logistics company like UPS might invest in making the UPS driver more productive, it's quite amazing. Then aerospace system with navigation, air traffic control. I had the chance to take part in a NIST study a couple of years back where they tried to look at some of the R&D challenges that could exist in cyber physical systems and define domains broadly. So these are just example systems I talk about, right? And then what domains do they serve? What value do we create? Things like smart manufacturing, improved transportation, infrastructure, healthcare, buildings, which is in and of itself a critical infrastructure, defense systems, first response, and then eventually, even to systems like smart cities that may happen. So in brief, CPS systems are everywhere, right? And they're a core part of our society and our infrastructure. And the challenge for all of us is now that these systems are getting integrated with IT systems, internet systems, is how do we make the combined system, the internet information and control systems, to be safe, secure, and reliable, right? Of its cyber control. And it's the changes that are coming are faster than we think, right? And so here are some examples of things where there is already a lot of commercial activity. I'll talk more about that later, but things like smart homes, automated navigation systems, the way vehicles do collision avoidance today, things like smart grid and demand response, using these computing and communication systems for diagnosis and medical delivery, they're here, right? They're having significant business impact. So the trajectory moving forward indicates that this is going to happen faster than we like. And I guess the hope is that security is not playing catch up again, right? But it very well might be. That's just the nature of things. So to think about cybersecurity broadly, a few companies got together to think about an organization we call Cybersecurity Research Alliance that Bill hinted at. And initial founders were AMD, Intel, Lockheed Martin, RSA, and Honeywell, and then more joined in. And we had a broad landscape of R&D problems we might want to solve. We had workshops with academia. Some of you participated. We had a lot of government participating in the meetings, thinking about how to approach it, what are the challenges, what are the models. And it's interesting that this group of companies, the first space we ended up having a more defined focus was around cyber physical systems. Because even though these companies serve different domains, this is the area where the industry felt if we can solve some critical problems, we'll be able to move forward. And the problems are in how to realize effective trust and security. So the workshop jointly conducted between CSRA and NIST. And by the way, we've had great participation from many government agencies, not just NIST, in getting to this point. And where the report came out, and here's just an example of how the industry likes to see some of these thought processes structured, right? There's a challenge around supply chain, which many of you understand. CPS, especially with the cyber plague that's coming, allows people to compose systems rather arbitrarily, and it's pretty easy to deploy something out there. So how do you do assurance and assurance composition for these systems? It's not easy to get reliable threat information. Can we understand what the attack domain looks like and what the systems issues are? There is infrastructure out there. There's both legacy and even recent infrastructure. How do we secure the base? That's a big challenge. Related to supply chain, but slightly different, when you build practical solutions and deploy products, you tend to source components from multiple places, and you just build on top. So what you take, you treat as a black box. How do you secure that? How do you enable trustworthy operations once you have deployed something? It's a broad landscape, but it's informed by how products need to be designed and how you deploy it and manage. So this is the focus on design and security, which is sort of one of the tenets of the federal R&D strategic plan that many of you are probably familiar with. Right. And so it's interesting. And more recently, I remember writing an article with David Nickel and Chris Sawal, who was then in Ameren, where we were thinking about what design and security can mean for power systems and for the grid, and also how do different stakeholders approach it. How does academia approach it? How does vendor approach it? How does asset management? It was a lot of fun, and we realized we don't always approach it the same way. We have fairly different perspectives. The question is, are we doing it right for the end user at the end of the day? So this is a busy chart, but I wanted to give a brief overview of how R&D program in cybersecurity for critical infrastructures was established at Honeywell, and some of this continues, right? It's first and foremost a systems focus to understand the domains in which we play as a company, but also domains in which key challenges exist and need to be addressed. And this particular thread of activity is looking at the grid in an end-to-end manner in what happens in generation, transmission, distribution, and consumer systems, as well as buildings and microgrids. And there are different types of commercial systems that we have that play in this space. Honeywell is a little bit more towards the right side of the chart as a whole, if you will, more on the load side and looking at buildings and microgrids, but there's spectrum, all of it. And we built a cybersecurity program to think about developing solutions in each of these domains, and then what is the end impact we might want to have there, right? So for example, we have a process control platform, and we looked at the secure architectures, and one of the key ways to have an impact was to influence the IEC 62443 standard, where our team members were key participants, because that is now seeing wide adoption in the industry. So it defines cybersecurity requirements for process control, and is becoming a de facto standard for how to think about security in that domain. And a lot of ways to do that, because the timing, this happened a couple of years ago, was at that time, the real value is to get everybody thinking of the same kind of requirements, right, as a big first step. On the transmission side, we don't do a lot of products, but we have services and look at SCADA type architectures. So we built a role-based access control solution I'll talk about more in partnership with the University of Illinois, and looking at how that can impact SCADA systems out there. In distribution consumer systems, we looked at homes, we look at smart grid, we look at demand response, we developed architectures, influence product development, and then look at some key protocols in this space. At some point, Zigbee was a leading player, maybe not so moving forward. We'll have to see how that plays out. But the secure architecture we designed should help elsewhere as well, if you look at the SCP profile open ADI platform. And then in buildings, the same thing, and microgrids, thinking about requirements, architecture, components, way to verify the trust and security system, and then move it out there. A lot of this work was informed by R&D and in partnership with universities and other companies, right? Don't want to do this alone, don't need to do this alone. So we have about 6 to 10 R&D programs that got funded in this space from various agencies, Department of Energy, Department of Defense. We actually even have an NSF proposal, which is not very common for industry, with Kansas State in this space. And the European Union funded several of these programs as well. And the focus is broad, looking at process control, microgrid systems, smart grid systems, the design of security of specific control devices, thinking about the users who design and manage the system, so an anthropology view on this environment, and then intrusion detection as well. So that's how we've been approaching it and trying to connect the dots between what is the end system that we want to influence, what our impact we want to have, and what's the best way of getting there, partnering with different organizations. So I'll give one or two examples of programs that we sort of saw some benefits from this, and then one or two examples of what's ongoing. I won't go through that list of projects. Maybe that's a separate talk. We can dig deeper in each of the R&D programs, trying to stay at a higher level today. So this is an example for a SCADA network diagram for process control, right? So many of you are familiar with it. There's a Purdue model level design. It's a zone network. There are 4 zones. And when you start documenting what are the weakness or potential attack paths, you can enumerate a lot of issues that happen, right? And these are sites. This program was focused on the oil and gas sector. And these are geographically distributed wide sites. And they have, if you think about their mission and their focus from a technology perspective, the big thing is safety and availability. It must run for 2 reasons. One, there's a business purpose. So if this plant stops, the cost is very high. So there's a business purpose to what you're doing. You're producing energy or producing some solution out there. And the second is something goes really bad, you can have things that go boom, right? It's a tricky environment. And then to do that, they design these zone networks and then have a lot of failover capability in the zone networks. So that's a mission-critical environment. So this project that we worked on was done with partnership with the University of Illinois, Idaho National Lab, sponsored by the Department of Energy. Tom Markham at Honeywell led it, did a great job. The program ended recently. And in order to look at the security for the environment, the team came up with some simple goals, right? Practical, simple goals. It is to secure legacy equipment while maintaining use of shared passwords, to specify and enforce least privilege, to secure the communications that exist in this environment, and to promote a common access control model. So the team started digging deep in understanding the environment, speaking with actual stakeholders that do this. Why is this hard? Why can't we just replace it with something better? What does it take? In doing so, some interesting R&D challenges emerged, especially when thinking from a role-based access control perspective, which from a policy point of view was a good way to address the environment. So one is that unlike other RBAC domains, say medical field or financial field, the number of objects are many more. That was an order of magnitude more. That was a challenge. Second, there's an object hierarchy in play, right? But the permission inheritance does not align with that hierarchy very well and can require exceptions in how you manage it. And even though that's how access is managed, the location, the policy and the access right management quite often has to be done independent of location and devices. So how you do the administration of the roles is tricky as well. So, it's deep practical problems, very hard to have an impact on. So in fact, the Illinois team helped us think about a scalable policy model that worked in 3 tiers here, right? To define and enforce privileges at the user level, at the application level, and at the node level. And this architecture remains consistent in process control, and you can realize good value from that. And then the Honeywell team looked at how to integrate this with field devices and deploy a solution out there. And Idaho National Lab helped evaluate the solution to make sure that it meets some right measures. So it's doing well, and it's going into the product development cycle now, and we hope to see good come out of it. And another technology transfer here is Dr. June, who was a postdoctoral research associate here, is now working for Honeywell. So we did that tech transfer as well, and he's helping us do great things too. Maybe 1 or 2 examples of ongoing R&D programs, and what some challenges. One is microgrids, right? It's about comprehensive campus energy management. It's becoming of increasing interest to deploy it, and the reason was mentioned on the bottom right. The mission for microgrid systems is multifold. One is to provide additional energy security while adding renewable resources, right? If you do renewable only in the grid, it's hard to realize how to do energy security. And they do it by having some storage and demand management on site. Increasing the reliability, right? At the crux of it, a microgrid should be able to disconnect and reconnect back to the grid on demand or on a failure. And improved efficiency. Because you have some on-site generation, you can do things to improve the efficiency. So a lot of the technologies that go in there are around energy management, on-site electricity generation, on-site storage, realizing advanced control, for example, how you would connect and disconnect from the grid, how you might do demand response, and so on. So a good example here is a microgrid facility Honeywell runs for the Food and Drug Administration. It's a 55 megawatt facility, and in the first 3 of operations, it's had 70 connects and disconnects from the grid. Some intentional, some by accident, but all pretty seamless. So, and there are many more, right? That's the only one I'm familiar with at that level of detail. And it shows that they really provide value, and as you deploy them, people do more and more with microgrids over a period of time. So on the left here is a program that we're looking at microgrid security. It's an ongoing research program with the Department of Defense through their ESTCP program. And this is in partnership with Army Seoul right here in Champaign, Fort Bragg, and PowerSecure and Sandhills Utility. And the idea here is to add additional layers of security, cybersecurity, deploy them and verify them in practice. And the other part of the project is to look at this notion of assured enclaves. A lot of the time, people are able to invest in microgrids of a certain capacity, which may not be enough, and then they want to increase the capacity. But today, when you add the second microgrid, it doesn't play seamlessly with the first one. So how do you create an architecture where you're able to scale microgrids seamlessly, so you get the benefit of 2 plus 2, if you will, while adding cybersecurity on top? Another program we're excited about is one on the right is the energy sector security appliances. This is led by the North American Electric Co-op Association, ENRICA. We have Honeywell, we have Pacific Northwest National Labs, CIGL and CMU, and it's another DOE program. And this one is looking at monitoring and response by developing effective appliances that can sit at the grid at different levels. So it could be something the co-op can use, it could be something that a utility can use, and trying to look at data-driven ways to do monitoring and response to the system. It's early, but exciting program. I think some interesting things might come out of it. So technology transfer considerations. So when I had a chance to observe how things get done in industry, right, it's a step forward in terms of being closer to the products and services, but it's not always easy to develop a solution, especially in partnership with multiple people, that can have an impact. So we worked over time to think about, what are the things they want us to think through to try and solve this problem. And we reference a lot of the literature out there on tech transfer models, and people get it right to some extent. But it's important to first know what type of solution you have. So are you building a prototype? Are you building a new technology, a new tool? Are you looking at a new standard? Just developing principles. So having some idea of the objective helps. And then it also helps to think about, what's the level of change you're hoping to have in the environment. So are you looking to do something incremental? For example, you want to speed something up to make it twice as fast. Or you're looking for some sort of a sustaining change, where you are replacing a process that is manual with something automated. Or you're doing something disruptive, where you're creating a new need, whether it's known or unknown. But despite that, I would argue a lot of the research, and present company excluded, right, focuses on one thing and one thing alone. That is looking at the capability of the solution in terms of what requirements it satisfies and what are the key properties it have. That's a lot of the focus, is hoping that we have a solution where the requirements and the solution is so compelling that nothing else matters and the solution will find its way to reality. It works in some ways, right? When you have that kind of a magical idea, sometimes the rivers part and you're okay, you'll get to the other side. But that doesn't always happen. So starting with capability, I'll talk about the few things that if you think about, we have found some benefit in approaching problems with that kind of a thought process. So you have the property, right? Let's say it's intrusion detection. Great requirement. Early days, there was just no way to solve it. So even when the first people did packet inspection, it was so compelling that it found its way into solution. Whether it was effective or not could be improved over a period of time. But when we look at our CPS space, you also have to think about how has that solution been customized, or how that environment is customized for the types of devices, networks, protocols, and applications in that environment. Beyond that, think about what is the broader acceptance criteria for such a solution in that environment. What standards do they look for? What are the interoperability requirements? Is there any certification or testing you might need? The earlier you can think about it, even having a capability that's accepted becomes more interesting. Move to integration. The solution has to be deployed in an environment of use. It has to be integrated with everything else that's happening over there. There is usually a development or deployment life cycle in that environment. If it's an engineering organization, they would have a way to do requirement specification, architecture, design, development, testing, validation, deployment, certification, maintenance, upgrade, use. There's a life cycle. Where does the solution fit in, right? Some thought can help. The end-to-end supply chain, to the extent that's possible to determine. If a solution requires modification of 3 components, but by the way, those 3 components are sourced from 3 different companies or 3 different sectors, your chances of implementing it starts to go down, right? What's the end-to-end life cycle? And then this environment, once deployed, especially in CPS world, has risk, compliance, liability. What reporting do they need to do? What's the risk that they have to mitigate? What liability might they have? You might have a solution which increases monitoring, and then you find out you can't deploy it because it increases the liability, because without a way to fix the solutions, you can't decrease the liability, and that's the primary objective. And last but not the least is some thought and awareness of the human factors associated with that environment. In general, what's the organizational awareness, right? Do you have a lot of people in the environment that are experts in understanding what you do? Because if they don't understand it, they may not be willing to deploy it. What do the decision makers care about? What are their priorities? Somebody's going to use the solution. What are the skill set of the technology developers that are taking your solution and deploying it? And then finally, the technology users. What can they do? What interfaces do they need? If you think about a lot of the usability research that happens today, it's primarily focused on home users, right? Trying to understand their ways to deal with security better. There is not enough research on what the mindset of the common developer, the common architect, the engineer who configures systems, the configuration management. What do they need? How do we make it easier for them to understand security deployed? There's limited, so people struggle with that. So I'll give you at least one example on the integration side, right? So you think about static code analysis, right? So again, not a very perfect technology. Lots of errors, not very easy to use. So, but it fits in the development lifecycle very nicely, because every company has to compile the code and take it through a testing process. So they found a way to develop a technology that fits very nicely into the development and deployment lifecycle, and it got a lot of adoption and a lot of good increase, and it helps. So that thinking can help in how you build solutions, how you get out there. Let's switch gears a little bit, right? That's an example of how we've been thinking, designing systems, what we've been doing. Let's switch gears a little bit to Internet of Things. I want to talk about it briefly and think about, jointly with you whether this is interesting or not. So one of the comments we hear quite rightly is there's a lot of legacy base in the CPS world, and it's hard to fix. And that's a fair comment. It's not an easy problem to solve, and it's big. But think for a moment, why does legacy exist, right? I can't imagine vendors saying, no, we should not sell updated systems. Let the old ones remain the way they are. Or even an asset owner telling his or her boss that, I know you have budget for more equipment, but I think we should stick with the old one. Right? That's not the reason why we have legacy. It's the inherent fundamental business models of how these systems live and how they operate and how they're used. The value proposition is a 30-year return many times, because that's the value they provide, and that's how you justify them. And they're meant to be there 30, 40 years. Of course, you get that only when you're also designing systems with that reliability. right? To the credit of these systems, they do have the reliability to be in the field for 30 years through all sorts of environment conditions. So it's an engineering feat of great achievement, right? That you can build a box that sits in environments for 30 years and still does its job. But the fact that you can do it and the fact that the business models don't motivate change faster is partly why we have a legacy problem. What can change? What can be new or different? So I'll go back to the IT days, right? Many of us remember the 90s and the mid-90s, right, when the internet world was being formulated, right? And cybersecurity was a big challenge. You don't know how to get it right, what to happen. And early around 2000, 2001, a lot of main websites were getting hacked. Pages of big companies were coming down and having a tough time figuring out how to secure it. And then the whole e-commerce field was invented, where there was a value in creating e-commerce so you can generate new business models out of it. And then people said, oh, by the way, I can't do e-commerce till I can do secure financial transactions. I can't do secure financial transactions until I have a secure internet or somewhat secure internet. So now security got into the critical path of realizing e-commerce. The minute that happened, the speed of solution development went up like crazy, right? And suddenly you have at least TLS came about, right? We have some way to solve it. It doesn't solve our problems, but it went happen. So look at it today, right? The global IT market is about $3.8 trillion. The global cybersecurity market is about $86 billion. Now, I'm not saying security is or should be an IT problem, but there is some relationship between these two, because you develop cybersecurity and target it at the IT systems. You may be solving business problems, but you're targeting IT systems. 3 to 4%, right? 2 to 3%. And it's kind of tracked that way for a long time, because that's how it's been motivated. So today, IT is not growing as fast. It's a 3 to 4% growth. Cybersecurity is going much faster. It's 8 to 10% growth. So it's time to play catch up, right? The systems are out there and see more security. And maybe this path will change out in the future. But nonetheless, business growth is where cybersecurity solutions tend to get some traction and go where they go. So the question is IoT such a market where things could be interesting, right? So the global IoT market is estimated at $2 trillion by 2020. Another data point is there are about $5 billion connected devices today, and they're projecting by 2020 it'll be 25 billion. These are projections, right? So you can take it with a grain of salt, but it's tend to grow. Is this an area where, because of the business motivations, things will happen faster? Could we see the product life cycles of the IT world now come to the CPS world? They didn't exist, right? 3 years is a fast life cycle for CPS. It's extremely slow for an IT company. They would be out of business if they dealt with 3-year product life cycles. And 3 years is now considered reasonable for CPS in many domains. It's getting shorter. I went to the Consumer Electronics Show in Vegas this January, and there was about a quarter mile of IoT demos, right? It was unbelievable, 900 exhibitors. 900 exhibitors, quarter mile of IoT demos, right? Your feet are hurting by the time you went through it all. And it's a change. There was no IoT at CES 2 or 3 years ago. There were a couple of fledgling companies. The speed of change is very interesting. So if I got a short video on that, is it possible to run that?
Yeah, it's on about.
It's all about connectivity at the 2015 International CES, and the Internet of Things is making it possible to connect just about everything to the Internet. We're here at CES Tech West to witness how this technology is making a huge splash across the show floor.
I really think it's going to be towards creating a responsive home that is able to understand what's going on.
There are 20 billion appliances that are going to be connected all together.
So it's a great way. If you think about an Internet of Things, you want smart data so that you get smart data in, smart data out, and to get a smart Internet of Things.
More than 900 exhibitors are here this week showcasing the Internet of Things. It encompasses everything from smart home security systems, connected refrigerators, cars, and more.
Yeah, we're Stack Lighting, and what we've brought to CES is Alba, the world's first responsive light bulb that has embedded light and occupancy sensors. So while we have an app, you don't have to touch the app, and it understands how much natural light is in the room and whether people are even in the room and whether it should be on or not. So we make it far, far simpler than all the other connected light bulbs.
So we have a universal remote that connects you to all of the appliances in your home for home automation, digital media, Internet of Things, home security, everything.
Gartner technology forecasts predict the Internet of Things will grow to 25 billion units sold by 2020, nearly a 30-fold increase from 2009.
We are a typical platform for Internet of Things that enable manufacturers to be connected. We converge it into one mobile app, meaning that the user now has this amazing...
So it goes on, right? Well, it was very interesting to observe this dramatic change. I'll talk about it. Right? It's noisy right now, and on that floor observing it, you're reminded of 1996, 1997, where there's the .com era, and you know all these .com sites are not going to survive. You know it, but the ones that do may change the world. It'll be different, right? How it works. So it gives you pause. So if you combine the notion of CS and IoT, the challenges are we designing CPS system for this scale where value and risk are both high priority? This is a key point because today, when you think of research that we do, we focus primarily on risk mitigation, right? What can go wrong and how do you prevent it? We are not designing CPS systems from the ground up on what value they create. And there's not enough research on what new value is being created. This world says designing for value as important as designing for risk. Both are important. And the comment about shortening product life cycles, it's a big, big change, right? And it's an opportunity because in the IT world, when we try to introduce cybersecurity, we were able to, whatever we do, right? I'm not arguing that our systems are secure by any stretch of imagination. But whatever level of security we have came through huge trial and error in the industry, and the trial and error was permitted by short product life cycles. If you have 8 to 10 year life cycles, you don't have the opportunity to experiment. It does not exist. So what is IoT, right? And there's so many definitions, and is it simply the consumer device world, or is it something more? And that's an interesting question. I think it could be something more. So here's a little view of the technology and business way of how IoT is actually happening, right? So start with the layer that says deployed systems. So this is the CPS world today. There are edge devices that connect to some kind of hub. The hub connects to some kind of middleware. There are applications that are on-site or remote, and there are services. There's a community of workers that install and maintain this system. Someone comes and installs a thermostat in your home or home security system. Someone comes and installs a system in the building ceiling. Then the users of these systems out there, right? And it's there for homes, there for buildings, there for industry, it's there for all sorts of things. That's a very high-level cartoon representation of how these systems are actually deployed out there. What technology enhancements are being envisioned by IoT is first realizing intelligence in the devices and hubs. Second, connecting them to the internet. Most of what you see out there stops there. Right? They're connecting it because they can. So you have smart toilets, you have smart toothbrushes, because they're connecting it because you can. And there's enough excitement in the industry that itself is getting a lot of funding, right? Huge funding is going just to do that. But you can also connect it to the cloud system. You can do data management. You can do mobility, or you can do wearables. These are some dimensions of technology enhancement that the IoT world can envision. A lot of it is not fundamentally new. It's an integration exercise, right? And a weak one at that in practice sometimes, but that's happening. But why it is getting some interest is because it creates new kinds of values. Just doing this creates new values. It can lower the cost. You can allow for data analytics monetization that may not exist previously. You can, for example, via mobile devices, do anywhere, anytime, any place access, which could not happen. And you can realize an enhanced experience right? Let's take some examples of what that means. Connected thermostats, right? Many companies sell those. In full disclosure, so do we. But it's there, right? So you can deploy it. What you do is you take a Wi-Fi thermostat, you use a home routing networking system, and you create connectivity for that stat. And now you can change your temperature anywhere, anytime, any place through a mobile device, right? Some of these, at the same time, many of these devices added more intelligence, so you can now do a DIY install. You can do it yourself. So you don't need to pay an install or commissioning guy to come and do it anymore. So you save the cost in the install. You can do it yourself. So you can buy it on retail. And so that intelligence came in. You get anytime, anywhere access, and you get better experience overall. You are more connected with the comfort of your home. You're less frustrated, right? Creates value. It doesn't stop there. There is data on what's happening in that home, and you can deal with it. So if you share this data now with the utilities, you can create very nice demand response systems, where the utility can use the data to first determine if there is load available in that home to shed. You can estimate demand response capacity, and you can actually send a message to change that through the same thermostat. Now you realize the ability to do data monetization on top of that solution. So you benefit the homeowner, right? You increase energy efficiency. You improve the capability of the utility to deal with things like renewable and whatnot. You create a societal benefit. That's a nice story. You get to do a few things there. Smart cities we keep hearing about, right? An interesting example I saw was the East Coast, a couple of cities are doing smart trash pickup, where they have trash compactors and a sensor in each trash can. The goal, simply tell through a network whether the trash will be picked up or not. So now cities can route their trucks and decide what to pick up smartly and save them tens of millions of dollars. Simple, but it creates value because it lowers the cost of the system. Someday you can use that data to find out how best to organize communities, because the presence of trash and how it's increasing can actually give you a lot of insights on the societal environment there, right? So you can do so much more. I don't think they've done that yet. But every time you do this, you get smart city data monetization will come into play. Connected cars. We're all observing our cars are telling us when the service is due. It can make your appointment for you. It can get you to the service dealer. It's almost like it's becoming driving as a service opportunity. So, but then someday they'll be connected to the transportation environment and transportation systems, right? What will you do out there? Fitness. I think there were several million fitness bands sold in US alone last year, several million. So clearly there's an interest in understanding that data that people have. It hopefully improves experience, but it has not yet been connected to the healthcare and wellness domain, right? That's the next opportunity for them. If you can do that, you'll create more value. So the idea is today IoT is focused on consumer devices and focused on simple connectivity. But the question is there a bigger, brighter future of more things you could do to real societal benefit? Right? What could you do? And there are many, many domains. A few that we have an interest in are things like connected homes, right? So not just having a light bulb that can do things for the sake of having a light bulb, but what else can you realize with that? Can you do better comfort and efficiency in your home with these systems? In certain parts of the world, can you use this technology to improve the air quality and the water quality of the home systems, right? Could you think about better home security? Ease and convenience also matters, right? If it's able to improve the workflow of the homeowners and the residents, it has some value. And all of this will be realized by solutions that just connect devices, mobile applications, different kind of software services, data analytics, a lot to come. An area that's near and dear to my heart right now is connected buildings. I live and breathe technologies that can improve commercial buildings. So, the last question, how many are feeling warm right now? How many are cold? What can you do about it? Not much, right? So we spend, 10, 12 hours of our days in buildings of some kind, whether it's our office environment, whether it's an airport, whether it's a hospital, stadium, and you don't have much autonomy. If you're used to it. If you think about it and spend some time saying, what else would I like from my building? you start to see an opportunity for societal change, right? What could we do? What can we think about? For people that manage these buildings, right, if anybody gets a chance to go and see the boiler room, the chiller plant of the campus, I'd encourage you to go talk to those people who manage it. It's not a simple life. They do a lot of hard work to keep these things alive. And how can we improve their experience? How can we help them manage the building more efficiently and reliably in an easy way? How can we reduce risk and so on? So again, a lot of opportunities that will have real impact and be realized through sensors, devices, universal software, applications. Analytics is going to play a key role. A lot of the data from buildings today just gets thrown away. Nobody does anything. It just gets thrown away. The workers, right? The people who manage buildings, the people who drive logistics trucks, the people who are medical and healthcare professionals. What can we do in this new world to improve their productivity, give them more enhanced safety, give them more accuracy in the data and security in the data so they can do job more productively? If you make this folks more productive, the end environment becomes a lot more productive and creative for us. So a lot of opportunities there that we can think about and work on. So that's another space that's of interest. Then the question is, so what does it have to do with cybersecurity, right? And we know we have to create trust. If you start doing searching for IoT on the internet, it quickly comes about the number one issue is security or lack of it. Well, no surprise, because if we're designing a system without thinking about it, clearly we know that's the problem that's going to happen. And chances are there that we'll repeat the mistakes of previous systems that we built, and maybe there's an opportunity to do it right. If you know about the Open Web Application Security Project, they maintain a top 10 list of things. It's very useful list. Not all of the top 10 I've studied in depth, but they have a main top 10 for web applications, right? Cross-site scripting and all sorts of other issues that remain number one for web applications out there. They created a list for the Internet of Things top 10 in 2014. If you look at the list, it's fascinating. It basically tells you everything is broken, right? So if that means when they studied IoT systems, everything is broken. They don't have secure web interfaces. They don't have secure authentication, network services, transportation. Privacy is an issue. They don't have good cloud interface. They don't have a good secure mobile interface. Insecure firmware, poor physical security, right? Everything is broken.
Why are people buying them?
It's a good question on why people are buying them. So security does not become a concern for citizens till the attack affects them. Right? Just the fact that it's insecure does not have much meaning. So even now, right, with all the big credit card theft that took place in 2014, are people demanding that they change the credit card infrastructure? Is the US going to move to chip and pin within 24 days or 25 days so that it adds more security? It's not simple, right? I don't have good answers, but it's not happening, right? Half the world has moved to chip and pin, but we're not doing it yet. So, good.
If you're going to make a top 10 list, you got to put 10 things on it, regardless of their importance.
Fair enough. So this is, think of it as representative, right? It doesn't have to be. But nonetheless, this list tells you what all the near-term challenges for IoT are. Right? These are the kinds of things that have to be solved before you can have some level of trust in IoT systems deployed out there. And that's a simple opportunity, is to figure out how to design solutions and how they get adopted out there. So when you look at some of the companies that are trying to do it, what they're doing is they're saying, I have an IoT framework, like a development environment, if you will, and then I've got security built into it. But in order to realize value, you have to use their development environment, which may or may not be fully interoperable with everything else because there aren't that many IoT standards to begin with. But how can we get best practices out there that address these type of issues? And then there's the R&D play, right? What are the longer-term IoT security challenges? So there's a lot of good work going on that's going to play an R&D role in this space. So, we're doing a lot of research on understanding attacks, whether it's the internet or different systems. We're developing theories, mechanisms, system security, focus on metrics and policies, because without policies, metrics are little value, and CPS-specific security measures that are going on everywhere. So All of this helps. And the question that we can ask is there something that we are not thinking about in this IoT world, right? What could be new and different that we haven't really fully captured? That's a tough question, nothing I have great insights on. It's more of an open challenge for people to think about. A couple of observations, if you will, right? We spent a lot of time saying that in the CPS world, CIA has a different set of rules, right? I talked about oil and gas sector earlier. We said availability becomes important, more important than CIA. So CIA becomes AIC in some domains. And we started building principles. Well, the IoT world kind of shakes that up all over again because you don't know anymore where the most important function lies. Because it's so intertwined, the values from physical or cyber systems, that both become important. Then the question of scale. If you're really going to have 25 billion connected devices, how are we trying to approach security that can try and deal with that scale? Do we have any ideas, or are we sort of, is the idea that somehow everybody will do the right thing because we have a lot of experience knowing how people do the right thing, right? So how do we deal with that? And usability will play a different role as well because now the number of interactions with people is going up orders of magnitude. So we've thought about security on a website with a lock that you can see. How do you deal with security in this converged cyber-physical world where I'm seeing something, touching something, and the system properties are emergent and they vary over time? How do I know I'm interacting in a world that I can trust? What does that mean in this new world? So that's all I had. Thank you. Open for questions. Go ahead.
Hey, Himanshu, I'll go first. First off, Bill, to answer what you were asking earlier, in my experience, going back from the days when I was working at one of the first internet service providers, users will trade convenience for security when things are emerging. And the question I have is really about, as researchers, what is it that we need to do to get inside the life cycle of this emerging technology? Because by the time it gets to be 2020 and there are billions of installed devices, any of the research that we may be doing now, it may be too late to impact the security posture of those billions of devices. What kind of advice do you have for the researchers to get within those life cycles?
It's a good question, right? And I'll make a conjecture rather than answer your question, right? Someday, just like we sort of have convergence on internet networking standards, and what does it mean to have an internet-based network system and intranets and corporate networks? Someday there's going to be convergence on what is a home network. What is a standard network that can exist, let's say in a building or an industrial plant, that allows for system devices to sit on it? If you think about those architectures and then develop security for them, we have some hope of trying to achieve scale, because then people who are designing those systems have to abide by the rules of that network. Today, that's not the case. You get to develop a device and the network that goes with it. So it's a hard problem right now. Maybe someday there's going to be a convergence of the approaches. And if you can target that convergence, maybe the chances go up. Right?
Yes, thank you for your talk. That's wonderful. But it only confirms my suspicion that we don't actually plan. We've known about the Internet of Things for 15 years. I was sort of doing a project early on, proposing all sorts of Internet-connected things. And the thing that stood out then was the lack of security and the problem about availability. And, this hasn't changed over 15 years. In fact, if you go back, I'm sure that, other older people than I could relate stories that are very, very similar. So there is a lack of taking ideas about security and applying them to new inventions. And it's almost sort of an availability problem, because we do not make those ideas available to the designers, to the future planners of these systems. I'm reminded that your area that you described is not the only one where there isn't any, or not much planned security. You have a lack of security in in the way that software-defined networks are being designed. You have a lack of security in the way that cloud systems are being designed. You have a lack of security in the way that automated car transport is going to be designed. So overall, I think you mention a problem that has existed for multiple, perhaps even centuries, I don't know, a long time. How do you, as a businessman, because you're in commerce, how do you get the government to actually make initiatives to improve security?
I can't get the government to do anything that's beyond my power. But to answer your question, Roy, it's a hard problem, right? I don't know, because it's how do you change an ecosystem because it's designed the way it is, right? How do you change venture capital decisions that prioritize security over features before they get out there, right? It's tough. The only thing that we don't do in research that people do in practice, in the business world, it's emphasis on continuous improvement, not on absolute security. Okay, and we tend to criticize systems that don't have a certain level of security, but don't make a lot of effort or observe whether there is improvement in that environment. And if there's a way to think about continuous improvement in our design, in our observations, in our support for the infrastructure out there, there may be a path to getting there. Right? That's the business world. Am I better than I was yesterday? Right? Everything is measured by that, as opposed to, is this secure enough? In some domains, that question does get asked and does get answered. But in other domains, it's improvement. So I don't know if I answered your question, but that's just one thought.
Question from online. Are there any security standards or standardization activities for IoT cybersecurity?
I'm not sure, but I know IEEE set up a working group now, standards organization for IoT. So they're trying to define what that means and what the interoperability would be. And there are some consortium led by industry that are looking at IoT development frameworks. And they do have some security considerations for that. But I'm not aware of any significant body that's targeting that question specifically. But there might be.
Okay, so from your perspective as an industrial guy with Honeywell, okay, so what sort of big catastrophes can you think of that could happen in the next 5 years because of our lack of thinking about security?
Let's end on a positive note, right? So I'll comment that this way, right? So we looked at the top 10 news items for 2014. And a big one was credit card and credential violation. When you look back 4 years ago and asked a group of experts, can you predict what would happen in the next 4 years? What are the big news items? Let's especially imagine the day or the month after Stuxnet came out, highly sophisticated attack, and you asked experts to predict what are the biggest news items you will see in 2014. I think not one would have predicted credit card theft, right? Not one. They would have imagined stuff that requires, instead of 20 PhDs, 100 PhDs to imagine the most sophisticated thing out there that you could go and bring down the world, and everything come crashing. But what do we have instead? We have credit card theft. It was a smart attack from a technical point of view, trying to get to this POS, point of sale system devices and to capture data before it gets encrypted, knowing how the memory systems work. Not trivial, I would say, but not something that requires 100 PhDs to put together. So the way I feel things will go down is the adversaries will target impact, not the mechanism of the attack. So to the extent we can imagine what that impact would be, that's where they would want to go after. But it can take many shapes and forms.
Great answer to a tricky question, especially when you're being broadcast to 50 more sites around the U.S. or maybe around the world. We never know. So thank you very much, Himanshu. It was wonderful to have you come back and see the impact you're having in industry. We all very much appreciate it.
Thank you, Bill. Thank you for inviting me.